So I got cut off at the end there. What have we done? If you've stuck with me this long, awesome. Let me just go back I want to go back a few steps. So we had this right here. We said this was the volume for the cap, and we broke it down into two integrals. We broke it, should box it a little bit better. So this was the integral to come up with the volume of the cap. And remember, the cap was this piece right up here that we're subtracting from this whole thing. If we found the volume of the cap, we would be golden. Okay, so this right here is the volume of the cap, and we broke this down into two integrals. Was this? I did the second one first. I did this one first, and I found that this integral, this integral was equal to 0.403, and then the last video, I just did this integral, which was also a little bit of a doozy, but that came up to 0.547, and subtracting, so that's that negative sign right there. So right there we get 0.144 is the volume of the cap. So let me go back up here, and we're ready to answer the question. So 0.144. So this right here is 0.144, and 8/9 is 0.889, and when we subtract these two, we get 0.745. Okay, so that is the answer to our question. What's the probability that this equation has no real roots? This is 0.745. Wow, that's a lot of work to do that. I'm going to show you another way to get the same result, and this is a very numerical method. So let's go right to Excel. If you've stuck around this long, thanks so much. So here's an Excel spreadsheet. I labeled 3 columns, A, B, and C, and I said A, B, and C were chosen randomly from 0, 1. Well, Excel has this wonderful function called rand, open parentheses, close parentheses, and this will give you a value, you guessed it, between 0, and I'll just keep giving to you 0 and 1, and not including 0 or 1. It's just random numbers between those two values. Okay, well, I just did it once. Let's do it 3 times. Look at that. Those are randomly generated numbers between 0 and 1. 3 of them, A, B, and C. They're completely independent. So what's the next step? Well, the next step is let's see what b squared squared minus 4ac is each time. Okay, so this equals b squared minus 4 times, what's my a times c. Oh, look at that. Lots of imaginary roots for that one. Let's do it again. Oh, it's negative again. Now it's negative, 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 lots of negatives. Oh, there's a positive finally. We could do this all day and we could count, but the great thing about Excel is it's never going to get tired. We might run out of memory or something, but we can do lots of simulations. I'll move this column over a little bit. And so let's do 10,000 simulations. Ready? Watch this. I'm going to take this, start dragging it down. Oh, look, it filled in. It just gave me all these other iterations of our random process. And let's do some more. How many you want to do? Well, we could go far, but let's do. See how it's zooming down like that? Let's make it do I don't know, 10,000. This is the great thing about Excel, is that you can ask it to do this and it will. And let's see, this is like watching gas going to a car here. All right, almost there. 9,000, 10,000, or 10,000. Okay, let's do like 10,000. I forget what line we started on. Let's go back up to the top. We started on 3, so really to do 10,000, we should get rid of this one. Get rid of that line. Clear. Okay. So what are we interested in? We're interested. We just did 10,000 trials. So let's just say imaginary root. Is it an imaginary root? If, so this is an if statement, if this is less than 0, right? If it's negative, then we do have an imaginary root. So let's assign that a value 1, and if it's not, we assign it a value 0. And let's do that for every single iteration. So watch what we do here. And take this, we just took that formula, go down to the bottom, back up to the top, paste it in. Now what do you think we're going to do? We're going to see how many 1s we have there. So let's sum up. Let's just count them all. Sum all of them. Boom. And Excel's working. So there's 7,324, right? And to find any probability, we take the number of successes, divide by the number of trials, and this tells us in a simulation right here. Oops, I divided by 1,000. I'm supposed to divide by 10,000. We found that, at least that was the 10,000, 73.82%. Let's run another simulation. That time 74.42%. That time 74.58%. And that time 74.645%. So this jives well with our analytic result of 0.745, and it's not always going to be 0.745. You can see it's gonna move around a little bit, but it's always going to be close to that. So that's using Excel to run a simulation. There's a lot of cool things you can do in Excel, and well, if anybody made it this far in the videos, well, thanks for hanging in there. I'll leave on that picture right there. I love that picture.